there's about 3,700 satellites orbiting the Earth, and they are not floating in the sky. Today, some people think that rockets take their payload, satellite, go straight up, drop the satellite, and the satellite hangs in the sky. Although, a rocket launch usually goes like this. It starts at its launch point, like Cape Canaveral. It'll go straight up. Then it begins something we call a gravity turn. It'll begin to turn, going towards horizontal to the Earth. Eventually it will be horizontal. By this time it'll be at the second stage of the rocket. From here, it'll create what some may call a circle. This is called an orbit. Most think that orbits are perfectly circular. Actually, they're an ellipse, or an oval. Since orbits are not perfect circles and they are ellipses. In this orbit, at this point, the satellite is 500 miles above the Earth. At this point, it is 400 miles above the Earth. In this situation, this point would be called apoapsis, the highest point a satellite reaches above the Earth. In this point, periapsis, the lowest point it reaches above the Earth. The Moon also has lowest and highest points. For example, here it is at the apogee, the highest point it reaches above the Earth, and here the perigee, the lowest point it reaches above the Earth. Orbits can seem very confusing. Gravity always pulls us down, so how come can a satellite circle the Earth? Sir Isaac Newton used a cannon to explain how orbits work. Let's say the cannon fired its first shot at a low velocity. The first curve would look like this. Perhaps the next shot had medium velocity. The curve would look like this. It would go quite far across the Earth, but it would hit the ground eventually. Now the cannon fires a shot that is going extremely fast. The shot is going fast enough that it curves, and the curve matches the curve of the Earth. Therefore, in a perfect vacuum, it goes all the way around and hits the cannon. For a practical example, the ISS orbits 254 miles above the Earth. Currently, it is traveling 4.76 miles a second, or 7.66 kilometers a second. This allows its curve to match the curve of the Earth and go all the way around. Orbits are not always the same speed. They depend on how close to the Earth you are. For example, this orbit is very close to the Earth. It is traveling at a very high velocity. Although this orbit that is farther from the Earth compared to this orbit is going much slower. Now, obviously you've seen astronauts walking on the surface of the Moon. They are obviously not being pulled towards the Earth, even though they are close to the Earth. This is because of sphere of influence. The Earth's sphere of influence is 1.5 million kilometers, or 0.01 AU. The Moon also has a sphere of influence. This means if you come within 380,000 kilometers, you'll be in the Moon's sphere of influence. The Earth will be no longer pulling on you, and you will instead be pulled by the Moon. Since you can cross spheres of influence, interesting things can happen. For example, Apollo 11, the first manned mission to land on the Moon, crossed the two spheres of influences. Apollo 11's orbital journey started with a low-altitude parking orbit around the Earth. From there, they accelerated by burning their engines. They made their apoapsis reach within the Moon's sphere of influence. Since Apollo 11's apoapsis was now within the Moon's sphere of influence, they could accelerate and enter into the Moon's orbit. Once the Eagle had detached from Columbia, landed on the Moon, done experiments, and then redocked, they were able to leave again. They then accelerated in the direction they came, which is actually decelerating from the Moon's orbit. This trajectory left them on a collision course with the Earth's atmosphere. By the time they got there, they would have accelerated using the Earth's gravity and reached 12.4 kilometers a second. Thanks for watching. Please remember to like and subscribe.